Hello, everyone. Thank you for joining us at Illuminate 2020. This is our first session in the DevOps track. In this session, you'll learn about AWS Observability, a new solution launched in August 2020, which helps infrastructure and DevOps teams unify visibility and monitoring for their apps and services running in a complex AWS landscape. My name is Bashyam Anant, and I lead product management for advanced analytics. I'm joined by my colleague Rishi, and I'm going to let him introduce himself and take us through the first part of this presentation. Rishi?
Hi, everyone. Thanks so much for tuning into this talk. I'm Rishi Divate, Principal Product Manager at Sumo Logic, responsible for solutions, apps, and partner integrations. So before we jump into the details of our new AWS Observability solution, I wanted to highlight how our customers are running their applications in AWS and the challenges they're running into. So AWS encourages the use of separate AWS accounts for cost management, security, and administrative purposes. Across our customer base, we see that close to half our customers are using 2 or more AWS accounts. Furthermore, again, close to half our customers tend to run their applications in multiple AWS regions to better serve their end users or customers in those geolocations. Now, once you're in a given account and region, you have a multitude of services that your apps can use. So we have seen that a typical Sumo Logic and AWS customer is using 21 AWS services. Also, within each service, you can have multiple instances of that service. For example, you could have thousands or hundreds of EC2 instances. The challenge here is this complex hierarchy of accounts, regions, services, and entities can create data silos where it can be difficult to get comprehensive visibility of AWS service health, especially given that we have disparate data sources coming from AWS for monitoring. For example, CloudWatch metrics, CloudWatch logs, and CloudTrail logs. Furthermore, when deployed, these AWS services are often dependent on one another. The challenge here is when there's a production issue, our customers have to go through a lengthy manual investigation process of running ad hoc logs and metrics queries to figure out the root cause. So with our AWS observability solution, we are addressing these challenges by unifying visibility across AWS hierarchies and providing the ability for fast troubleshooting via a machine learning-based Root Cause Explorer add-on. So now let's talk about how this works. So with unified visibility, you can navigate across account, region, service hierarchies in Sumo Logic in the UI via our Explorer interface. You can also search across these hierarchies using both logs and metric searches. For example, you may want to see all the errors or exceptions in a particular account, region, or service. We also have over 40 out-of-the-box dashboards that are specifically built for comprehensively monitoring AWS services across all available data sources. So whether it's our EC2 host metric source, CloudTrail logs, CloudWatch logs, or CloudWatch metrics. So we have support for 6 out-of-the-box services, 6 key AWS services, and you have the ability to integrate new services in the solution as well. So our solution can easily be set up via AWS CloudFormation templates that execute in minutes. One key aspect to note here is we tag all of the incoming data in Sumo Logic with metadata about the AWS hierarchy. That is which account, region, namespace, or service, and entity or instance it belongs to. So this allows us to easily visualize and search across these hierarchies. So packaged within the AWS Observability solution, we have the Root Cause Explorer add-on that we introduced in August of 2020. So with that, I'm now going to let my colleague Bashyam Anant talk through the rest of the presentation and the demo.
Thank you, Rishi. Packaged within the AWS Observability solution, we have the Root Cause Explorer add-on, which we also introduced in August 2020. Root Cause Explorer is an AI ops breakthrough that helps DevOps and infrastructure engineers resolve incidents in their AWS infrastructure quickly. Root Cause Explorer embodies 6 key troubleshooting strategies that on-call staff are extremely familiar with. Let's walk through all 6 of them. First, it detects unusual spikes or events of interest in over 500 AWS CloudWatch metrics in the 9 AWS resource types that are listed on this slide. It does this after modeling the daily or weekly periodicity in these metrics. To do this, we leverage machine learning for every combination of entity and metric in your AWS account. In fact, in this screenshot, each dot that you see is an unusual spike in one metric. The x-axis is the timeline. The y-axis represents the extent of the spike compared to the expected value after adjusting for periodicity. And the size of the bubble represents the duration of the spike. The second strategy is we help the user correlate the context surrounding any event of interest. Such context includes what other spikes happen in the same time range as the incident, in the same AWS account, in the same AWS region, for the same microservice, and other factors. Third, we all know that a breakage in one resource or entity can cascade into breakages in connected entities or services. We build the topology of your AWS infrastructure to understand these connections, to group spikes together, and to find causal connections between them. Fourth, we know that the earliest spikes are closest to root cause. So Root Cause Explorer lays out spikes on a timeline like you see in this screenshot. Fifth, we know that often software defects or configuration changes are the first real root cause of an incident. To help the user detect those kinds of changes, Root Cause Explorer links spikes to logs associated for a particular entity. Lastly, Root Cause Explorer also classifies each metric into one of the golden signals of load, latency, bottleneck, or error. Simply put, unplanned load in one resource can lead to latency or bottleneck in a connected resource, which can then lead to errors. This classification can be helpful for root cause analysis. Let's take a look at all this in our demo. So in our demo, the first thing you'll notice is that AWS Observability is powered by the Explorer hierarchy. So the first thing that you'll notice is that automatically the system has actually figured out all the accounts that are connected to AWS Observability, in particular the dev, prod, and stage accounts, and then pulled in data from the region, the namespace, and then individual entities. So at each level, I can actually look at dashboards that are available for me, which are summarized information at each level in the hierarchy, again, at the account, region, namespace, and entity levels. So for example, if I want to look at my EC2 instances in aggregate, I can see that there are lots of things going on with many EC2 instances, and indicated by this honeycomb. And I can actually quickly drill down into any particular EC2 instance that's running hot, and I can pull up a dashboard for it with a lot of relevant information. Now, on one particular day, I want to look at my top level application load balancers, and I get a summary here at this level, and I notice one particular load balancer that seems to be having an elevated rate of errors. To pull up the dashboard for it, like before, I navigate to the related dashboards screen, and then very quickly I notice that there is actually a spike in 500 errors for this particular load balancer. So what's going on? To do that, let me go back to the region level and pull up the events of interest dashboard for the US East 1 region. And this particular dashboard is actually powered by the Root Cause Explorer technology. So one thing that you'll notice here is that in addition to the particular error that I was noticing in the application load balancer itself, many other things are also going on at the same time. Now, each dot in this particular scatter plot represents a single entity on which there is a particular metric that is spiking from the expected value after factoring for periodicity. The x-axis represents timeline, like we spoke about previously. Now, what is going on? So to do that, I actually open the details of this particular area on the on the root cause explorer panel itself. And one of the first things you'll notice is that the context that was there on the previous dashboard gets carried over. And in particular, I was in the US East 1 region and in the prod account. So that context got carried over for me. And looking at these particular timelines, so the problems seem to be happening around the 5 o'clock timeline. So actually I can actually zoom in and then see the particular things that are going on at that around the 5 p.m. timeline. Now on the right hand side, actually this is essentially the root cause guidance given to you right away. The thing to notice here is that a set of bottleneck events, specifically on this particular DynamoDB table, and a set of EC2 instances caused the actual error that the user saw in their application load balancer. So let's take a look. So here's the DynamoDB event of interest, and it tells you that the write throttle activity was throttled on this particular table for 10 minutes, starting around 5:10 p.m. And then you can actually verify that really quickly by looking at the time series diagram for that particular metric itself. Let's take a look at the EC2 instances themselves. So again, these EC2 instances are actually grouped together. Now, the reason for this is in the case of Root Cause Explorer, as we talked about before, we leverage the connections between the AWS infrastructure implied by the topology. And in this particular example, several EC2 instances, actually 4 EC2 instances belonging to this particular load balancer group were behaving anonymously with respect to the CPU load on them. So rather than showing you 4 different bubbles on the scatter plot, Root Cause Explorer aggregates them together and puts them as one single event of interest with 4 grouped events that you can look for. So in a nutshell, so what you have here is that the first level root cause indeed is this idea that DynamoDB throttling resulted in bottlenecks in several EC2 instances that were connected to that DynamoDB instance, which then cascaded into a set of errors that you saw at the application load balancer level. Now that's the first level root cause. The next thing you need to figure out is try and understand why DynamoDB got into a state where it actually got throttled. To do that, I actually look at the related tab, which actually pulls in several dashboards that are of interest related to this particular DynamoDB entity. So I want to look for the DynamoDB events table. And with my knowledge of AWS, what I do know is that if there are update table events going on this particular table during the timeline of interest, again, the timeline got carried over from the root cause explorer, then there could be a problem. So let's go and examine some of these events in the underlying log search itself. Now, what you see here is that lots of update table events were happening around the 5:20 p.m. timeline. And then if I go into the details of these messages, you see that someone was actually trying to change the provisioned capacity, provisioned IOPS for this particular DynamoDB table, but were actually not successful. So that's what you see here, the provision throughput parameters, write capacity and read capacity units, but it's actually ending up in an error state. So what had happened was that there was load that was coming on to the system. Someone tried to change the DynamoDB settings in reaction to that load, but were not successful, which then resulted in the DynamoDB table itself getting throttled and resulting in the cascade of issues with respect to EC2 instances that got bottlenecked, which then eventually resulted in the load balancer 500 errors. To summarize, what you're actually seeing here is that when you look at AWS observability, the first thing it does for you is to actually aggregate visibility across multiple accounts, regions, namespaces, and entities. And then with Root Cause Explorer, it pulls in the context and applies the 6 strategies that we talked about with respect to timeline, with respect to looking for spikes in particular metrics, building the correlation and context for you in terms of what else is going on in this around the timeline of the incident, looking for these kinds of spikes organized by the timeline itself. Last but not least, also looking for classification of these kinds of spikes along these golden signals of error, availability, latency, bottleneck, and so on, which helps you diagnose root cause really, really quickly. And then finally, with respect to the linkages to the logs themselves, where it makes sense, jumping into CloudTrail or CloudWatch logs that are related to particular events of interest that help you understand the true root cause behind these incidents. Root Cause Explorer was launched in August 2020 along with AWS Observability, and it went through a extensive preview program over the summer with customers like the ones that you see on this particular slide. The common points of feedback that we got from a number of customers is the idea that Root Cause Explorer helped them. The ease of setup was extremely valuable for them. In under 20 minutes, most customers started seeing all their metrics and log data related to AWS infrastructure flowing in, and the dashboards lit up. So that was a moment of delight for a number of customers. The other thing that a lot of customers acknowledged was the ease of use. So as we've mentioned, there are about 40 different dashboards at the 6 to 8 different namespaces that we talked about in this presentation. And each of these are actually packing a lot of subject matter expertise, which is hard to come by. So a lot of time savings and a lot of ease of use and productivity benefits is what customers acknowledged as for this product. And last but not least, with Root Cause Explorer, they were able to get to diagnosing issues in their environments really, really quickly. And there are actually two flavors of diagnosis many customers were able to do. The first was reacting to an alert, and the second was to actually understand failure modes. So especially in a large distributed system, oftentimes it's hard to figure out exactly what's going on and how your application or services might fail. And Root Cause Explorer is sort of used in that proactive manner as well to actually look back and see how applications or services are failing in production. To wrap up, three key takeaways. With cloud environments, there is a visibility challenge. In this example, you saw AWS observability solving for that challenge for AWS environments. Again, giving you visibility at the account, region, namespace, and entity levels across the various AWS services that we examine. The second thing is, given the complexity of a distributed application infrastructure, troubleshooting is cumbersome, and you saw how Root Cause Explorer can actually accelerate the first level and second level troubleshooting for customers. And last but not least, logs are still your friend in terms of deep analytics, in terms of where the real root causes might lie, especially to look for things that you can actually fix so that problems do not repeat again. We want to thank you for your attention, and we'll open up for Q&A at this point. Thank you.